Hello Year 10, it's Mr. Green here. I'm going to take you through a little revision session before your exam next lesson, and today the learning objective is to revise the calculations for the energy unit. If you just pause the video while you write that down as your heading. Okay, so today our learning outcomes are to revise for the upcoming end of unit test. That is the overview of this unit. There are 9 sections of the topic we were doing. Think about this topic and which one you're most confident with and least confident. Write that in your book. If you pause the video while you do that. Okay, once you have a record of that, make sure you take a note of that and you use Educate or any revision sessions that you've got, or even your books, to go through what you find the most difficult. What we're going to go through in this session today are the energy equations, work done. We're going to talk through power, efficiency and specific heat capacity as well. So I'm going to take you through all the calculations, giving you some examples, giving you practice questions to do, and then there'll be a worksheet at the end to practice all that you've got. So, to start, these are the equations we need to know and learn. Please copy these down as they come on the board and pause the video once they're all on display so you get them all down. We have potential energy. Gravitational potential is mass times gravitational field strength times height. Kinetic energy is half times mass times velocity squared. Elastic energy is half times the spring constant times the extension squared. Work done is force times distance. Power equals energy divided by time. And efficiency is useful output divided by total input multiplied by 100. That would give you a percentage. Okay, pause the video while you copy all those down. Okay, so let's start with the first one, gravitational potential energy. Here's an example. Calculate the gravitational potential gained by Emil, who has a mass of 85 kilograms when he climbs upstairs of height 5 meters. So we'd start with every calculation, we write down the equation we're using. Gravitational potential equals mass times gravitational field strength times height. The mass is 85, we get that from the question. Gravitational field strength is always 10. If it's happening on the Earth, the value of G is always 10. Make a note of that. Make sure you know that for the exam. And the height is 5. So when we multiply those together, we get an answer of 4,250 joules. So get all the information from the question, place it into your equation, calculate that through. Okay, 3 questions for you to do here. If you could pause the video while you attempt those questions, I'll then take you through the answers. Okay, question 1. Gravitational potential gained by a ball of weight 0.75 when it climbs a height of 2. So the mass is 0.75, height is 2, and 10 is the gravitational field strength, giving you a value of 15. It does not matter what order you calculate these because they're all being multiplied with each other. So 0.75 times 2 times 10 gives us 15 joules. Question 2. What's the gravitational potential when a 0.25 Christmas tree is resting on a science bench 1.5 meters high? Well, 0.25 times 10 by 1.5 gives us 3.75. Question 3. Mr. Green's dangling the engine of his dodgy VW Polo out of the RE window. What's the engine's GPE? Well, we can see there the mass is 50, the height is 8.5, and gravitational field strength is going to be 10. So we have an answer of 3.75 joules. Pause the video to get those answers down. Correct with your green pen. Okay, kinetic energy. So, here's an example. Usain Bolt has got a mass of 94 kilograms and reached a maximum speed of 12.2 meters per second. What's his kinetic energy? Kinetic energy is half mv squared. That's mass times velocity squared. So we take our values from the question. His mass is 94 kilograms, so that's half times 94, and his velocity is 12.2. So that's 12.2 squared. Now we do that before anything else in the equation. Come up there with a value of half times 94 times 148.84. That's 12.2 squared. Multiply that by 94. Kinetic energy is half times 13,990.96. Divide that by 2. 6995.48 joules. Pause the video so you can copy that sequence down. Okay, here's some questions for you. 5 questions to calculate the kinetic energy. Again, if you could pause the video while you attempt these questions and restart it once we've finished. Okay, question 1. A car with a speed of 20 meters per second and a mass of 1200 kilograms should have an answer of 240,000 joules. Year 11 pupil, mass of 55, swinging back on the chair and falling off it at a speed of 0.6 meters per second, 9.9. A runner with a mass of 62, running at a speed of 0.8, 19.84. A tennis ball travelling at a speed of 46 with a mass of 58, 61,364 joules. And a dog running across a field at a speed of 1.2 meters per second with a mass of 3.2, 2.304 joules. If we've got any of those wrong, or if we're struggling, please go back, rewind the video so we can see the example that I've given, and then look again at what you're doing with your answer, taking the right values of velocity and mass, putting them in that equation, and turning them around the same way. Okay, elastic potential. Our question is, what is the elastic potential energy when the spring constant is 15 newtons per meter and the extension was 2 meters? Well, the extension is half times spring constant times extension squared. The spring constant is how much the spring is going to stretch when it's given any sort of mass on the end of it, and the extension is how much that spring extends, not the total length of the spring, how much it extends. So we place those into our equation. Half times 15 times 2 squared. Again, we square that 2 first. That becomes half times 15 times 4. 15 times 4 gives us 60, and so half of 60 is 30 joules. Again, when you're writing your answers, please place every single step down in your book. This gives the examiner a chance to mark any sort of work you've done. Even if you get the answer wrong, you'll get some sort of credit for doing the right sequence. Okay, 2 questions for you on this one. Please pause the video while you attempt those questions and remember to write it out correctly. Okay, question 1. The elastic potential when the spring constant is 2166 newtons per meter and the extension is 0.3. We know our elastic potential is half times spring constant times extension squared. 0.5 times 2166 times 0.3 squared. Square the 0.3 first, multiply it by 2166 and then by 0.5, gives you 97.47 joules. Question 2. The elastic potential when the spring constant is 4266 and the extension is 1.3. Our spring constant is 4.266, our extension is 1.3, so 1.3 squared times 4266 times 0.5 gives us 3604.77 joules. Again, pause the video to make sure you've got that. Green pen your answers. Okay, work done. How much work is done when a force of 20 newtons pushes an object a distance of 50 meters? Well, from our equations we can see work done equals force times distance. In this case our force is 20 and our distance is 50. So it's really simple. Work done is 20 times 50. Gives us 1000 joules. Here's some questions. Okay, try and work out the force. When I'm talking about weight, remember weight is a force. So you'll need to rearrange the equation. Work done is force times distance. Rearrange the equation first and then attempt the questions. Pause the video while you attempt those. Okay, question 1. Work done is force times distance. So force is equal to work done over distance once we rearrange our equation. Force in this case is work done is 1500 joules and the distance is 7.5. 1500 divided by 7.5 gives us 200 newtons. Question 2. A chicken is dragged 19.6 meters with work done of 342. What's the weight? Again, it's the same rearrangement. Work done divided by distance. Force is 342. Sorry, work done is 342. Keep saying that. And the chicken is dragged 19.6. 342 over 19.6 gives us 35.6 newtons. Okay, second set of questions, but this time I'm asking you for the distance moved. So rearrange the equation again. Try and calculate the distance. Again, pause the video while you attempt that. Okay, then question 3. So to calculate the distance, when we rearrange the equation, distance equals work done divided by force. But again, be careful with the question. It says 17 kilojoules. We need to convert that to joules. So our equation would be 17,000 divided by 45. Work done is 17,000. That comes out to a distance of 377.8 meters. Question 4. A 98 Newton box that needs 3,456 joules of work done to move a certain distance. Calculate the distance. Again, we've rearranged the equation. Distance is work done over force. Distance is 3456 over 98. That gives us a distance of 35.2 meters. Okay, power. What's the power of a crane that uses 1,050 joules of energy in 50 seconds? Power is energy divided by time. So the energy is 1,050, time is 50 seconds, 1,050 divided by 50 gives us a power of 21 watts. Remember, power is measured in watts. Okay, 3 questions on that. Pause the video, be careful with question 3. Make sure you convert everything. Okay, pause your video, attempt those questions, restart when we need the answers. Okay, question 1. Power is energy divided by time. We can see there energy is 1,000 times 3 seconds. 1,000 over 3 gives us 333.3 watts. Question 2. Power is 100,000. 20 seconds is the time. Energy over time. 100,000 over 20 gives us 500 watts. What's the power when Mr. Green uses 50 joules in 3 minutes? Power is energy over time, but time's in seconds. So we need to convert that. 3 times 60, 180 seconds, divide 50 by 180, we get a value of 0.27 watts power. Okay, our final equation we're using is efficiency. So a light bulb uses 250 joules of energy, 225 are converted into thermal. What's the efficiency of the light bulb? Thermal energy in this case is wasted, so we want the useful energy in this case. Useful energy would be 250, take away 225, getting rid of that wasted energy, leaving us 25 joules usefully used. Efficiency is useful over total times 100. So our useful is 25, our total is 250, times that by 100, you get 0.1 times 100, giving us a percentage of 10%. Again, 3 for you to attempt there. Please pause the video while you attempt them. Okay, question 1. A motor that uses 2,000 joules converting 800 into movement. 800 joules for energy, so it would just be 800 divided by 2,000 times by 100 gives us 40%. Question 2, a radio that uses 800 joules converting 500 into sound. Again, 500 useful, so it's 500 divided by 800 times by 100 gives us 62.5%. Question 3, a TV that uses 1,500 joules converting 800 into light, 500 into sound and 200 into thermal. In this case, both light and sound are useful, so we add those two together, giving us a value of 1,300 joules. Divide that by 1,500, we come out with 87% efficient. Okay, I've provided a set of worksheets that contain a variety of calculations, all of the ones we've just used, all of the equations that we've just gone through. I'd like you to attempt every single question, and next lesson you have an exam. So please revise. Please use all the resources that you've got. There is Educate work set, so you can have a look at those. Best of luck, and I will see you next lesson. Thanks a lot. Goodbye. Have a lovely weekend.